Alright, gonna just do a demo here of actually loading up this part without imparting the major stress concentrations you get right where if you put a load right on nodes or constraints right on nodes, you always get big gradients because they are singularities. And what I'm going to do here is use a little thing in Nastran called the RBE3, which is an interpolation element that really doesn't impart any stiffness, but it can actually connect up the nodes and we can put our constraints and loads on. First thing we need to do is just mesh this part. And let's just do mesh solids. I'm not sure what material. I'm just going to make it out of aluminum. You can obviously use whatever material you want. I'm going to tighten up the mesh sizing around the holes because we do have those little tiny holes. Let's go down to 12.5. And this little thing here gets rid of, we'll let it tighten up around the holes. So you can see now the mesh size is much tighter in there. We'll say OK. And our part is now meshed with a really nice tight mesh around the hole, so we will see at least the stress gradients as we want them. Now the trick here is to create these rigid elements, and I'm just going to hit model element, which is Control E, and then change the type. We're calling it a rigid even though it isn't. It's very similar with the center node and all the connections. So we're going to go to this RB3 element. And since it's solids, there are no rotational degrees of freedom. We're just going to do the translational degrees of freedom. And to pick the nodes, I'm just going to pick the two halves of the hole and let Femap create that rigid element in there. Now we're going to do the same thing on the other locations. So new node at center, nodes, method on surface. And let's do it here. And then we'll slide over here and do it on surface. We actually have an API that does this automatically. If I was going to make these all the time, I think I'd switch that over to making RBE3s, but just for this thing we'll go ahead and just finish up doing it by hand, and then we'll go up to this one and we're going to pull on that hole up there, so we'll pull one there too. So nodes on surface, these are just making those little spiders. Okay, and here's the one we're going to load, this one in the positive Y direction, but we need the same thing there to apply the load. Okay, so what we're going to do is just temporarily, I'm going to go over here to elements, by type, just turn off the solids, I'm going to turn off the geometry for all I'm seeing those now is those 6 RBE3 elements. So the first thing we want to do is hold them down, so I'm going to create a new constraint set, which is the fixed at 5 holes. And then what we'll do is let's open up that constraint set and say nodal, and we just want to go for that middle node. We can see it highlight in the middle, and we pick those 5. And again, there are only rotational degrees of, translational degrees of freedom, so we'll go those directions. And now we need our load, so I'm going to come over here and create a load set. Actually, we want to do an enforced displacement, don't we? So let's do it that way. Let's do model constraint nodal, and this is kind of new in one of the most recent versions of Femap, but we can just put in enforced displacement on as a constraint. So I'll pick that middle node there, and we have this non-zero. And let's just make this thing move a little bit in the Z. Say 01. So now our model is set up and ready to go. We just need to set up our Nastran run. So I'm going to say just a new, it already knows about the constraint set. There's really not much to do. Now one option here that's key is this auto MPC. What we've done here is we've got degrees of freedom constrained and connected and all these things. This just tells Nastran to auto sort out any dependencies and get everything right. And I think that ought to do it. So if let's just save it, and then we'll hit analyze. So Nastran's going to run here. We should knock this out pretty quick. Still running. The rotational degrees of freedom, I could get rid of that message. We'll just let it fly. So now it's solving. It's already done reading the results. I'm going to turn off everything but the elements just to clean up the display, get rid of nodes and stuff. And let's just take a look at deformed and stresses. And you'll see now you kind of get realistic stress concentrations around holes. I mean, that's kind of what you get without anything going really crazy, but that all seems to make sense to me.